All right. 9 o'clock, and you're all in here for FHIR Server, so you may applaud for yourselves. I think so. So what's the question of today? Is, well, a FHIR Server, nice term. It's all over in the spec, except there's not much definition of it. There is, but you have to look for it. So what functions does it actually have, and what could I use that for? So who's the audience? Well, obviously you are. This is a high-level session. If you are very seasoned and experienced with FHIR servers, use them all day, build one. Everyone seems to do that nowadays. Then probably this will be too basic for you. But if you're an architect and wonder how you could actually use this, or you want to integrate systems, where does this FHIR server come in? Then you're good to go here. There's no code involved, unlike my previous session on Wednesday. Who am I? Well, this is me. I work for FHIR, and I build a FHIR server myself, our FHIR server, so that's why I know about all this stuff. What's the agenda? So what is a FHIR server? We're going to see what functions it can have. What types of servers there are, and what are the use cases? What can you use them for? You can ask questions. It's here at the end, but you can interrupt me as well. It just might mean that we don't get to the end of the presentation. So what is a FHIR server? There's one statement in the spec that tells you what it is. It's any software that implements the FHIR APIs and uses FHIR resources to exchange data. Well, that's fine. So a lot of people start with FHIR by reading the resources because that kind of maps to their domain knowledge. You know about observations, or you know about lab results or whatever. And then a server is some piece of infrastructure that just there to make sure your resources are still there tomorrow if you want to put them somewhere. But it can actually do a lot of things. The FHIR spec also has a page that says what interactions are all defined for FHIR servers. That's here. I'll show you. This is actually from the http.html page. So there's a lot of infrastructure pages. And I turned the definition a bit to this. It's any software that implements all or several parts of the FHIR RESTful API. And that's that all or several is key, because a FHIR server need not do very much to be a FHIR server. Essentially, if you can deliver an empty capability statement, you're a FHIR server. Not useful, but you're a FHIR server. All right. To get acquainted with this, I urge you to experiment with this. First of all, there are 2 pages in the specification that you would definitely want to read about this. That's the HTTP-HTML and the search.html. With the thing in front like hsl7.org/FHIR or the build.org/FHIR if you want the latest version. You'll be able to find this. It's a whole list of public testing servers, including our own, vonk.fhir.ly. But Happy has one, Eightbox has one, Graham has all versions running on test.fhir.org, and there's even more than that. So that allows you to interact with FHIR servers, see what they do, how they differ. Some points in the specifications aren't completely to the finest detail specified, so servers may differ in their answers. If you want to experiment, most FHIR servers respond to you with XML or JSON, depending on what you ask. That is best used with an API testing tool like Postman or Fiddler, or maybe the developer tools in your browser. But using the normal browser interface is usually less useful because you can't inspect the headers that come back or more detailed information. One other important piece is we provide a cheat sheet with all the major commands of the FHIR RESTful API and how to use them. And if you think that's too hard or not enough, it also has a convenient reminder of the next DevDays in Redmond. So take one if you want. They're also at the booth. We have plenty. So what's all in that server knife? One important observation is that FHIR was invented for interoperability. And then hence they invented the resources, which have a nice little, they have a nice boundary. They are self-contained, so they make a nice way of interacting, of conveying data to another party. But then somehow the FHIR server was invented, and so well, now we have to store these resources. So people started thinking on how to do that. That led to resources as a unit for storage and ways of storing that in an actual database. There are several ways of storing that, but it's a whole new paradigm actually. It's not just interoperability, it's now you have a database that's capable of storing FHIR, including an interface to talk to it, which is the RESTful interface. Unfortunately, it's a bit less intuitive to talk to it with SQL, as you might be acquainted with. So, every database needs a data model, and FHIR provides one, but there's no standard mapping to this. If you have it in a certain database model, you might be able to use capabilities of that database and that model to query it directly without the RESTful API, but that is dependent on the server implementation, and that has nothing to do with the FHIR spec itself. That said, there are a couple of servers out there, quite a lot actually, that have a storage model that looks a bit like this, because the question is often asked, how do you store this in a relational database? Well, most of the servers out there, probably not all of them, but most, have some kind of table with resources in them, either for each resource type a table or all of them in one table. And they keep some metadata about the resource, and they keep the original format of the resource, either in JSON or XML or some lossless format. Then next to it, they keep some indexing tables, because not every search parameter is easily searchable in JSON, because either they are correlated in a way that's not easily expressible. If you have like quantities, you want to be able to search them on different units, and all kinds of optimizations or calculations you can do in a search index. Usually these are separated for the types of search parameters that we have. We'll get to a search page as well. I'll explain more about that. Then you can add a full text index, or maybe even if you're Google, you can add your Google search to it to provide searching on all the text of the resource, and especially also the narrative. So what does this all enable? First of all, the CRUD. Everyone familiar with that acronym? It's for creating, reading, updating, deleting, so actually managing the resources that are on the server. That's pretty straightforward actually. And whatever you can create, you can still read afterwards. And that might seem logical from a database perspective, which it is logical for a FHIR server perspective. But if you come from an HL7v2 background, this might not be so logical, because there you send a message. You can't read it back because it's gone. So this is it's quite a bit different in that case. But it also implies that you have to store these resources somewhere, otherwise you can't read them. There are a couple of additional features here, like conditional, which is possible on create, update, and delete, and it has different meanings on the different things. A conditional create means create this if it's not there yet. On an update, it means update it if it's there, and maybe otherwise create it. And on a delete, it allows you to delete multiple items at the same time, or one that adheres to your criteria. And then we have patch. That's a bit newer, and that is also interesting, because if you read a resource, we saw about GraphQL yesterday. I don't know who has seen the session. It was a bit less high level than this. But if you get only parts of a resource and you want to do updates to that, that's hard to do with an update operation. Because if you send an update operation, what will happen is it will overwrite the whole resource. So if you only send parts of it, you lose the rest. And that's why patch was invented, so you can say, I just want to change this and this and this, and leave the rest as it is. And that's more useful if you only have parts of the data, either because you don't want any more, because of bandwidth, or you're not allowed to see other things. So, then you want to be able to find this stuff. And there's a whole search API, and it's so big that they started to move it out of the HTTP page and to another search page. And it provides a host of parameters. I think this is one of the most powerful features of a FHIR server. It's actually search in different ways. First of all, there's the predefined search parameters. On every resource page, on observation, on patient, on risk assessment, there's a list of search parameters defined. It's always at the bottom of the page, so maybe you never made it there. And there's a couple of things to that. First of all, they have a certain type of search parameter, because it differs if you're searching for a string or you're searching for a code from a code system, or actually from a value set. Or you're searching for a quantity that may be in different units. There's also a search parameter for datetimes, because they behave differently and they have ranges, etc. And especially in FHIR, because a datetime can be of any precision. So a day spans a whole day, whereas a minute will only specify a minute. So that might be totally different. And comparing those is pretty hard, actually. So there are all these predefined search parameters with these types, and another important part of it is the FHIR path expression that tells you where in the resource that data is. Well, FHIR Server solves that all for you to make it searchable, and you just need to remember the name of the search parameter and query for it. Then there are custom search parameters, because you're allowed to define your own search parameters, just as the search parameters in the spec. Just make sure they have a unique URL, so we can identify them. And some of the servers are actually capable of digesting your custom search parameters and adding them to the search index. There are some more advanced parts. It's _filter. Hardly anyone has implemented that yet, but it's a more elaborate query syntax. And there is _query for predefined queries. So let's say you have some very sophisticated query in your that you can implement in your database, and you want to be able to call that by name. So you query for all the observations that were done yesterday, but by a specific doctor, something you can't express in the search API. You could devise a specific query for that. Obviously, that will only work in your environment for people who know about that query, and you can't easily move it to another FHIR server, so it's less interoperable. And that's GraphQL. There was a whole session about that yesterday, so I won't elaborate on that. Here's an example of a search query. It allows you to search patients that are in a group with this ID, and they belong to an organization called this, and they have been born since 1982. Wouldn't know why you want this intersection, but it shows you a couple of the capabilities of the search API. I won't go into how you implement this. Then there's history and versioning. Most FHIR servers are capable of keeping the history of resources. Very useful if you get only a part of the data and you then update it, because not everything is lost, it's just in a previous version. And then you can also read past versions with underscore history. And interestingly, you can also query for the history of a resource, get all the previous versions, history on a whole type, get all the changes since a specific time of day, then or even for the whole server. That's interesting. If you want to periodically query for the changes on the server, you could just query the history and then get all the changes since your last query. Depending on the volume of the changes of on your server, that might be a lot of data. A point in time can also be interesting. Let's say if you did a specific research last year's November, and you want to be able to retrieve the resources as they were then. That is done by the underscore add. It is also, if you keep all these versions, it's auditable, so you can see when resources were changed, and if the server decides to keep an audit log, you can even see who changed it. Obviously, on the public test servers, you generally don't have to log in, so we don't know who changed it, and we don't keep a record of it. Then validation. This is an important part. Who here has by now heard of profiles? That's slightly over half. For those who haven't, a profile restricts the way a resource looks like, what a resource can look like. So it can restrict cardinality, it can fix a certain code to a specific value set, it can fix the set of extensions that are allowed on a resource, etc., etc. So that makes it possible to define it for your domain, for your project, for your country. We have a host of profiles, for example, for the MetMy project that you may have heard of, because there's a table outside of it, here in Holland. Argonaut is defined in terms of profiles on resources. And then it's useful that if you get data into your server, that you are able to validate against those profiles. Is this a valid Argonaut resource, or is it not? Is this a valid MetMy resource, or is it not? Or if something is in the server, you can actually ask it to validate it afterwards. So you might accept everything, but when you query it, you want to know whether this actually conforms to what you would like to have. So that's all kinds of forms of validation, and that's a very important piece of it. We find it actually so important that for Vonk we made it possible to connect your server to your simplifier project. So it knows about all the profiles you have in your project and is able to validate against it. The actual validation code is often not just in the server, it's often in the public APIs, as it is in the .NET. There's a Java implementation, there's a Delphi implementation by Graham. And the JavaScript implementation is coming together, I believe. So that's all good. You don't need a server for that, but you have to code to actually use it. And what it does in validation, you can just structurally evaluate the resource. Is it actually a valid FHIR resource at all? You can also evaluate the rules, the invariance. Who has ever seen invariance in spec? It's not too many people. Well, on every resource, there's usually down below the list of elements, there's a list of invariants, which is rules they have to abide. And they are usually expressed in FHIR path, and they should match. You can also check the terminology bindings. So if codes are used in resources, do they actually conform to what is in the resource defined as what value set should they come from? That could be defined in the core resource or be tightened in a profile. So that's where the core and derived profiles come from. So you can check, does it conform to the core profile or some of the derived profiles in whatever level, on the national level, on my regional level, in my organization, etc. What a server adds to that validation is that it provides it as a service, because this is a web service. So you can, and there's an operation for it. It's called $validate. And some of the servers are also usually capable of validating anything that comes in, which is sometimes a nuisance and sometimes very practical. And you can administer the profiles. So you can say, well, this server knows about these and these and these profiles, and then I can use them for validation. Because if you define your own profile, but the server doesn't know about it, it can never use it for validation, obviously. Also, you can connect terminology services to it, either in the service or maybe a connected specific terminology service that can be used to check the terminology bindings. Then custom operations. FHIR spec defines a host of standard interactions like the create, the search, the transactions. I haven't even come to transaction. I don't know whether it's, I don't think it's even in there. And then you may want to define other operations. That's possible. It's called a custom operation. And even in the spec, some of them are already defined, like $validate is one, $document is one, for those who have attended my previous session. And I just made a couple of them up here. A questionnaire, you could say, well, I have a questionnaire, populate this with data from this patient already that we know of, and then so the patient or someone else just has to answer the questions that we don't yet know. Or patient matching, you could implement that. But this requires, all these operations will require a definition, which in FHIR is an operation definition resource, by the way. And B, implementation in your server. And that implementation usually is not portable across servers because of the technology stack. And a server usually has some form of framework to implement them, either high level or low level or something to add that custom operation. Subscriptions, very useful. Something happens to the data and I want to know about it. I want to know when a observation is done with a very high blood pressure for a certain group of patients. Well, you can do that. It's done with a subscription resource. Again, everything is a resource, but not everything is a clinical resource. And there's a couple of structural resources here, or infrastructure resources that we use here. So you post a subscription resource and you define the criteria of when you want to be notified. And then when some data enters the server, either by a create or an update, you will be notified if it matches your criteria. There is an important note that in the current specification of subscription, you won't be notified if something does not no longer match your criteria. But it will probably be corrected in new versions. So this is a way to communicate with other systems or with users to inform them about changes. Can be on different channels, by the way. It can be REST hook, which is useful between web servers, or web sockets, which is useful for a mobile phone, or even by email or SMS, whoever wants that. Then, apart from using terminology in validation, you could also host a terminology service as it is in a FHIR server, or you can even create a FHIR server specifically dedicated to that. I know some people do that, which is useful if the code systems grow. So what you register here are primarily code system and value set resources. How this combines is a code system defines a set of codes, and a value set defines a set of codes you can choose from, but they could be of multiple code systems or a subset of code system. So the value set is what you actually supply to a resource or a profile for users to choose from. You can use them for validation, we saw that. You can use them for search. There are specific search modifiers that tell you, I want not specific, not this exact code, I want something that's in that code, in one of those codes, and or not, or something above or below. So if you have a hierarchy of codes, like in SNOMED CT, you can say, well, this code is right, or everything below it. that requires a lot of the terminology service to actually find the closure of terms that you have to match. There's a couple of specific operations defined for terminology as well. Look up, expand a value set, because it could comprise multiple code systems and subsets of that. So if you want to know what's actually in there. And a couple of others. And there's you'll see there's a tendency to define like simple code sets, a V2 code set, a table, or maybe just administrative gender. It has a couple of values. Or very complex code sets like SNOMED-CT or LOINC that are very hard to evaluate to get closures from, etc. And where you will need specialized terminology services for. The previous, the simple ones are often natively supported by the FHIR Server. The complex ones are not. Messaging. What does messaging have to do with the FHIR Server? Well, at first, not much. You can do messaging without the FHIR Server. That's perfectly fine. You have one client sending it to someone else and do something with it. But the FHIR Server may help. Messaging is still expressed in resources. It's a bundle, and it has a message header and on top of it, which tells you what kind of message it is, and then it has all the resources that are of interest to that message. It's a bit like a V2 message with all these segments in it. Then there's a process message operation defined in the spec, but it's very generic. It doesn't really say what you do with that message, so that will be very specific to your implementation of it. So you can implement that as an add-on or plugin or whatever your server provides to do that. It also depends on the types of messages that you want to process, so this is actually very dependent on the input parameters and the way you decide to implement it. But your FHIR Server can act as a receiver, because messages typically require that the receiver is online always, otherwise they go into the void. And since a FHIR Server is a web server anyway, they could do that, and they can also be a message store, because, well, a message is still a resource. It's a bundle resource. There are even a couple of search parameters defined for it. Authorization. Actually, FHIR doesn't say much about authorization at all. It used to do nothing of the source, but since version 4, large parts of the Smart on FHIR specification are moved into the FHIR spec itself. And that's actually very useful, because you can do all kinds of authorization, whatever fits your organization, but Smart on FHIR ties it down to a couple of more simpler choices. OpenID Connect, which is actually some kind of, well, not simplification, but it constrains the OAuth2 options. You can define per resource type for observation, patient, etc., whether you're allowed to read or write it. And you can even, it's not on the slide, but you can even say you are only allowed to read data from this patient and related resources, or this encounter and related resources. So you're confined to a compartment of resources. If you want to do another authorization model, which is perfectly fine maybe in your organization, but you can still leverage this canonical model, so you know what you can authorize on. You can authorize on the resources, or maybe on elements of the resources. That is harder to express, so you will have to find a way of expressing that. And you will have to extend your server to support that, because no server can support any authorization model that you can come up with. So that will be work on your side. Then the identity server, that is the part that's responsible for recognizing your users and telling other servers, providing tokens to other servers that will prove who the user is. It's not a part of FHIR. It could be part of the whole package, but it's not a function of a FHIR server as it is. Auditing, what happened on my server? Two important resources, provenance and audit event. A provenance resource tells you, is provided by the user of the FHIR server, and it comes with other data to tell where it came from, what it was originated from, who's responsible for it, etc. An audit event is typically created by the server itself to record what happened. It's like a complex way of logging, but a way that you can afterwards query in the same way that you query all the other resources. So that's useful. Then, bulk data export, get whole patient records, just like the $everything operation. I never mentioned that with the custom operations, but it's get the whole patient record for whole groups of records at the same time. There's a specific specification for that in draft still, but maturing. And we might even get an import counterpart. Very new is the SQL on FHIR initiative. Thank you, Ryan. And that's a way to define SQL queries on FHIR data. That's not natural, and it will require you to somehow reduce the original model. So it is probably a lossy transformation to make that possible. But if it contains all the elements that you're interested in for your research, that's not a problem. Mapping can be done in a server. There's a mapping language in FHIR, which has not been implemented a lot yet. But you can, for example, use Vonk as a Facade as well, and you provide the mapping simply in code. You can do the same in Happy. And then there's one very important part. You can actually ask the FHIR server what it can do. That's what I told you in the beginning of your FHIR server, if you can deliver an empty capability statement. If you actually can do something, put that in the capability statement. It's not capability statement or metadata, it's /metadata is where you find the capability statement. So it describes what you can do. It contains all the interactions, all the resources, all the search parameters on the resources, the way you can move from one resource to the other, etc., 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 and the software properties, by the way. You can use a capability statement also to express what you would like a server to be able to do. And then you can match those two. What types of services are there? I talked about a couple of examples here: Eightbox, Happy, Graham Server, the Microsoft Google Server. Well, they are in general generic resources. They support all types of resources. And, well, some or most of the API. So you can use it for anything, actually. But they're not highly optimized for something. They're not optimized to do terminology. Or maybe optimized for handling questionnaires. So that's where you would use a specific server and optimize it for a specific purpose. Like cutting meat. And you could also have a specific server for a project. Like you could have a MetMy server that makes sure that everything comes in conforms to the MetMy profiles. Another way of dealing with it is a facade. It looks like a knife, but it might not be one under the hood. And you can use that on top of existing data structures. You just FHIR defines a RESTful API. It doesn't say anything about what that storage should look like. So if you have a whole bunch of data, you can put that FHIR API on top of it. It just requires a lot of programming to connect the two. And then special mention, I think here, deserve the cloud FHIR servers. They're also generic FHIR servers, actually, but we've seen a lot of them here lately by Microsoft, by Google, by AWS, etc. So, but they are usually tailored to fit into the cloud offering of the vendor. So they use AWS Lambdas or Azure Functions or things that you typically cannot run locally. They have also a very strong point because they have the cloud to compute on. Then what do you use it for? I'll go quickly through this list. A clinical data repository. Many hospitals have, or other organizations, combine their clinical data into some form of harmonized database from all different kinds of sources. And how cool would it be if you can query that with FHIR? For instance, all the other apps or services that need data could then go ask it there through FHIR. So you can do that here, and this is a solution where you translate everything at the source level and then send it as FHIR to a generic FHIR server, and that will then be your CDR. It can use history, etc. That's one option. The other option is you already have this integration, and that's often the case. And it also has a massive advantage in terms of speed, usually, because these are often direct database connections. And then you can put a facade on top of it where you provide the mapping. Not always easy, because the data in the CDR is not often highly normalized, so you will have to fix that in your mapping, and that might have trouble on the, so you might lose the performance on the facade side. It's also a trade-off. If you do it this way, you get all the goodies of a FHIR server, like support for all the search parameters, that whole search index, etc. If you do it this way, you don't have any of that. You have to map the search parameters, you have to map the data. So there's always a two-way mapping here, one from the queries to your database, and then from the data from your database to FHIR resources. You can do that gradually, one at a time, based on as needed, but it's work. What functions does it provide? Of all the functions of the servers that we talked about, this is most of them you can see in a clinical data repository. Obviously searching and reading, but history and versioning can be very interesting as well, because then you are good to go for research as well. You can do validation on anything that comes in, or when you query it to see whether it conforms to a profile that you need. One thing we're thinking ahead of is maybe querying according to a profile, but that's future. Authorization, obviously, limit what you can see, provide a single authorization model on this large database instead of all the source databases. Subscriptions, if anything happens anywhere, then you can be notified, but there's something on the trigger for the subscription. If you use a generic FHIR server and send data into it through the API, it's easy to provide the subscription functionality. If you have a facade, that's harder, because then the data comes in a different way, and you will have to recognize that something has changed that might match a subscription. So you have to provide triggers to the subscription subsystem to evaluate the incoming resources. So this is also easier in a full FHIR server. Well, an obvious use would be to extract bulk data from it. Research and analytics. It's kind of enabled by this clinical data repository, and you could use bulk data export to another system, or use subscriptions to get it into a secondary storage. We experimented with a subscription that puts all the changes also in Apache Spark, which is a perfect analytical platform, and also supports, for example, the SQL on FHIR initiative, to see, but on a derived data model. So you can just explore your data more easily. And if you want to have it in a specific format, you might use a complete bulk data export and reform that to something you need in your research. Maybe you need it in SAS or SPSS or whatever. If you have a facade, it might very well be that your source data repository is already fit for SQL queries, and then I would skip the FHIR step. Extensions. Resource can have extensions. That's something to remember. And so they can have kind of extra elements in them, which are defined as extensions. And for query and analysis, that is a very hard task, because you don't know upfront what they will be and what's in there, and how they influence the meaning of what they extend. So if you want to do research and analysis, you probably code or reduce your view to the extensions that are of your interest. So if you are in the US realm, maybe the race is indeed of interest, and you promote that in your SQL representation to a specific column. Whereas here in Europe, you would probably not do that. And you can also add custom search parameters for extensions. That's very useful, so that makes it searchable by a common name. Then another usage would be to use it as an application platform. If you build apps or maybe plugins to the EHR or something that needs to read that data in some form, it's useful to use FHIR for that, especially for apps, because FHIR was partly invented for it. And then it's you can use this FHIR server as the generic backend. Apps just need to understand FHIR and the RESTful interface, obviously authorization. This provides a web API. It provides storage, it provides the history, it provides almost everything. So it saves you a lot of programming in your application backend. What do you use here? Obviously CRUD, which is something I didn't mention on the CDR. And that's not easily mixed either, because typically a CDR contains copies of data, derived data, and here it acts as a source of data, where you actually manage things in a transactional way. It's a bit like a transactional database is something different than a OLAP database. You can search, of course. Validation is very useful, especially if you allow multiple apps to connect. You make sure they can't enter anything that you do not allow. Authorization, and you may have some form in place to also put consent in here, but it's because that might be interesting if a doctor needs to wants to use an app to access patient's data. How do you define whether it's actually allowed? You can solve that once here and then be done with it. You still have to solve it, because probably you have rules in your own organizations that apply here. They may even differ per department, so there's no generic solutions for this. Useful though, there is a consent resource that can help you with this. And you can add custom operations that you need for your app. The whole concept of custom operations is you can make a FHIR server recognize birds if you want to. It's not really FHIR, but you can extend it any way you want. Another way of using it is for external data reporting, which means like you have to report to the CDC or here to the RIVM, which is kind of our counterpart to that. They would be able to only speak FHIR to other parties, or they could define profiles to deliver that data. Currently, you have probably for 100 reports, you have 100 different formats. That's a nuisance, but they will probably slowly evolve into using FHIR over time. And then it's useful to have a kind of a CDR or something, or you could have specific FHIR servers for specific reports, so you're sure they can't ask anything that are not allowed to. Or you provide multiple facades on the same source. Well, you tailor it to the usage at that end. Obviously, the FHIR server could also be on that side, and you send the data over there, depending on which organization you work for. What do you use here? Search. That's mainly if the data is on this side, so they search for that data that they want to have. History inversion could be interesting if there is discussion about reports. What was that data at the time you sent it? Oh, I still have it. Validation, because you have to adhere to the profiles at the destination. And subscription, maybe if something new comes in, you immediately notify the other party. Useful for outbreaks or something. Mapping can be involved if they want something different than you have, and bulk data export if you do this periodically. CDX hooks. I have 1 minute, so this will be very quick. CDX hooks defines a way to launch custom functionality from your EHR that is not in your EHR, like for clinical decision support. That's what the acronym is for. And they're allowed to get additional data from a FHIR server, and that is usually the EHR backend with a FHIR Facade, but it could also be a full FHIR server or your CDR where you have a lot more data than just your EHR. So, we made it just in time. Any questions? Then either I was very unclear, or yes.
Do you know any sites that are using the FHIR server as together with the normal infrastructure, so having data in normal relational databases, and then having a FHIR server used to maybe store data likewise, to have it mirrored?
So they use a FHIR server for mirroring the data?
Or you have a FHIR server maybe just for the purpose to have externals using the FHIR server, and then you have your normal backend relational database with the same data, but then you duplicate the data.
Usually then people start out with the Facade on that data, because replicating data is always pretty difficult. And if you want people to add data to your organization, then use a FHIR server for that specifically, and use that as a new source to a CDR, for example. So usually it's not very advisable to mix those two functions.
If you use the FHIR server as a Facade, what is the common approach to integrate with a data store?
If you use the FHIR server as a Facade, what is the common way of integrating it with the database?
Does the servers provide any tooling that are offered?
Yeah, servers do provide tooling for this. Not all of them, by the way. And for obviously for our own FHIR server Vonk, and for Happy, I know how this is done. And it's in different ways. But it means, usually it means implementing some kind of interface for the resources that you are interested in. And there's always a two-way mapping, because you have to map. They will break down the search API into separate components that you can then implement. And on the other way, because you have to translate that to a query to your database. And then on the way out, the data you get from your database, you have to map that to FHIR resources. And that's where the public APIs come in as well, because they have all these resources defined that you can then fill the elements from your data set. That's the generic approach. Yes, I think it's time. So if you have any more questions, I'm around here for the rest of the day. And otherwise, you can always reach me. Well, there was a slide in the beginning, or at vonk@phir.ly. That will also end up with me. Thank you.